Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about area between curves.
Minute Math, when you need help you use Minute Math.
We're given this problem right here. Y equals the negative x to the third over 2 plus 2x squared, and y equals the negative x squared plus 4x, and we want to find the area between the regions enclosed here. Now, one thing that we aren't given are where these equations intersect, and we can see that on our graph here. They intersect at x equals 0, 2, and 4. So from here, what we want to do is we're going to set up an integral with these values. We're going to integrate between the two functions, basically. And we're actually have two integrals, from 0 to 2, and then 2 to 4, because they switch on which one's on top there. So we need to set this up. The integral from 0 to 2. Between that interval, which one is the higher equation, higher on the graph, and that's going to be the negative x squared plus 4x here. So we have negative x squared plus 4x. We're going to subtract then this other equation, that's one that's on the bottom here. Okay, and that's a negative x to the third over 2 plus a 2x squared dx. Then we want to add the second equation here to it. And the second part is from 2 to 4. Okay? And this time, between that interval, the negative x to the third over 2 plus 2x squared is on top. It's a higher equation there. So we write that first. We have a negative x to the third over 2 plus 2x squared minus this other equation, negative x squared plus 4x dx. So now we set up a big integral, two of them, and we need to solve this. Now, same steps as before. Let's take our time. Let's simplify this out a little. Okay, 0 to 2 here, integral. Let's combine our like terms. We have a negative, well, the only one to the third power is this first one right here. So negative, negative, makes it a positive. We have x to the third over 2 plus, well, we have negative x squared minus a negative 2x squared, so that combines to be a negative 3x squared. And then we just have a 4x left over here, plus 4x dx. Plus, we're going to use the second integral from 2 to 4, same idea, combine our like terms. Negative x to the third power is the only one, the third power, so right from the beginning, negative x to the third over 2. And then we have an x squared. 2x squared minus a negative 2x squared plus a positive plus 3x squared. And then we just have a minus of 4x at the end, dx. Okay? So now from here, we need to find the integral of each one. Okay? So let's go do that. Well, the integral here of x cubed over 2 is x to the fourth over 8 minus integral of 3x squared is an x to the third power. And then the integral of 4x is a 2x squared. And this is integrating from 0 to 2. Same thing here, we integrate the second equation from 2 to 4. Okay? Negative x to the third over 2 is a negative x to the fourth over 8. Plus integral of 3x squared is an x to the third. And then a minus 4x is a minus 2x squared. And we're integrating this from 2 to 4. So then from here, we want to, well, apply our rules like we always do. 2 goes in for x first. Okay, so when I substitute 2 in for x and simplify, I actually get a 2. And we subtract that by when we plug a 0 in for x, and we get a 0. Plus, same thing here, when we plug a 4 in for x, I did it for you. When I plug 4 in for x, it comes out to be a 0. That's nice. Minus, when I plug 2 in for x in the second equation and simplify, I get a negative 2. 2 minus 0 is, well, a 2. Plus a 0 minus a negative 2 is plus a positive 2, plus 2. And hopefully we all know this, 2 plus 2 is 4. So after all of that, the area of the region enclosed by the curves is just 4. I hope this video is helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math, when you need help you use Minute Math.